These are the frequently asked questions for pre-calculus for section 4.7, day 1. We're going to start with number 3 here that says find the exact value where the inverse tangent would be 0. So what you want to think of is where is tangent going to be placed so that we're talking about the PBR, and then how do you get that 0? Well, the 0 comes from the fact that tangent is y over x, and we're looking at the quadrantal angles. So if we come out here on the unit circle, we have the point 1, 0, and 0 is our y value, and that means that y over x will be 0 over x. So we take a look at that and say, well, what is the angle that would give us this cosine and sine of 0 over 1 that would equal 0? Well, this is 0 degrees or just 0 for 0 radians, either way. So generally, if things come out to 1, 0, -1, you may be looking at a quadrantal angle. 1 is sometimes a 45, 45, 90, but most of the time we need to start thinking about those quadrantal angles. Then number 4. I've got a new drawing down here, but we actually could have just used the same drawing because notice that our quadrantal angle here has a cosine of 1. And so this is still going to be the point 1, 0 here. And since we want the angle, it's going to be 0 degrees or 0 radians. And I believe all these answers were given radians in the back. So just a 0 with no label on it would indicate that we're talking about radians there. Number 7. On number 7, they want a tangent that is going to end up being -1. So a tangent that is -1. What we have to remember is that tangents are going to be in these two quadrants, quadrant 1 and quadrant 4. That's our PBR. And a -1 there, well, if we're in those quadrants, we're not going to get a -1 on one of the axes to work with. So I start thinking this must be a 45, 45, 90. And if tangent has to be negative, it's not going to be in first quadrant. It's going to be in fourth. So I draw my triangle, and I remember that we have 1s and square root of 2s when we're talking about 45, 45, 90. But of course, this vertical distance here is now a -1. Not really a distance, I should say, but the coordinate would be a -1. And so we realize that for this one, if they want us to find tangent, which is opposite over adjacent, we're going to have a -1 over 1, and it will be -1. And this was a 45, 45, 90 triangle. We want a negative label on it, and we want to remember that 45 degrees is pi over 4. So this will be a negative pi over 4. So the drawings, I've talked so much about how trig is so visual. You have to get in there and draw, and you have to think, where is that PBR? Where should I place this? If it's positive, I'll go here. If it's negative, I'll go here, and then figure out where those numbers are coming from. Number 11 wants a cosine, inverse cosine that is 0. So let me get some room here to show you that one. All right, so inverse cosine, it needs to be 0, so remember where cosine is going to go for us. Cosine is supposed to be either quadrant 1 or quadrant 2, and if we're talking about cosine, it's going to be all positive over here, and this will be positive, negative, negative. But we're really interested in where is the x-coordinate going to be 0, because with cosine, remember x comma y, the x is always the cosine. So we're looking around for a place to put this where we'll have 0 something, and that's a quadrantal angle right here. This will be 0, 1. And then we realize, well, that's pi over 2. So pi over 2 will give us what we need there. Number 12, the inverse sine needs to come out to be 1. All right. So sine, we're going to be looking at quadrant 1 and quadrant 4, and they want this to be a positive 1. So start thinking, well, maybe this is a quadrantal, but maybe this is a 45, 45, 90. we need the sine, we need the opposite over hypotenuse to equal 1. Well, the hypotenuse in a 45, 45, 90 is the square root of 2, so that's not going to do it. So this has to be quadrantal. And I realize it either has to be here, here, or here. And what I need is for that sine to be a positive 1. And this, 1, 0, remember this is cosine and sine, that's not going to do it. But this point is 0, 1. And that's where sine is going to be 1. And that, of course, is pi over 2. Number 21 says, describe the end behavior of the function. Well, my first thought in this was, if you went back to your notes and you looked at how we graphed inverse tangent, you might have thought, well, is this going to work for x squared? Well, remember, we said for inverse tangent, no matter what x is, it doesn't matter that this is x squared. No matter what we put in for x, we are going to have a new domain from -1 to 1. And we are going to have a new range, negative pi over 2 to pi over 2. And in fact, these are asymptotes. So when we graphed the inverse tangent by switching the domain and the range, that was what we got. And you can see right there that the asymptotes are negative pi over 2 and pi over 2. So the limit as x approaches negative infinity for the inverse tangent of, it doesn't matter what, but they asked for x squared, we know from the graph what's going to happen to this. If it's x squared, if it's x to the third, it doesn't make any difference. If we go to the left forever, pardon me, this graph is going to approach negative pi over 2. And then the limit as x approaches infinity for the inverse tangent, again, of x squared, it doesn't matter that it's x squared, it just matters that we're finding the inverse tangent, is going to be pi over 2. It's going to approach it, but it's never going to quite get there. And that was because of the chunk of the graph that we had to take in order to get this to be 1 to 1. And it was the center that we had there of the graph of tangent that we used to switch the x's and the y's.